Okay, welcome to chapter 13, section 2 on working energy. We're going to talk about simple machines here, so let's get to the key ideas slash questions here. What are the 6 types of simple machines? What are the 2 principal parts of all levers? How does using an inclined plane change the force required to do a work? And what simple machines make up a pair of scissors? Alright, so let's start out with simple machines here. What are the 6 types of simple machines? So, the 6 types of simple machines are the lever, the pulley, the wheel and axle, the simple inclined plane, the wedge, and the screw. So, simple machines are divided into 2 families, the lever family and the inclined plane family. So, the lever family includes the simple lever, pulley, wheel and axle. The inclined plane family, the simple inclined plane, the wedge, and the screw. So what are the 2 principal parts of all levers? All levers have a rigid arm that turns around a point called the fulcrum. Levers are divided into 3 classes. So here you see the 3 classes of levers. You have a first class lever here at the top, has a fulcrum located between the points of application of the input and output forces, much like a hammer here. In this particular case, there's a force here and a force there. So, and the fulcrum is right here in the center where it is pivoting around. So, input force down here, output force up, fulcrum's in the center where it pivots around. Second class lever, the fulcrum's at the end of one of the arms, and the input is applied to the other end. So the wheel of a wheelbarrow is the fulcrum. So you're applying a force upwards on the end. The fulcrum's at the very end on the left here on the wheelbarrow where the wheel is, and the load or the output force is in the center. That's what you're lifting. Then you have third class levers. Third class levers multiply distance rather than force. As a result, they have a mechanical advantage of less than 1. Human body contains many third class levers where you have the fulcrum and the input force and then the output force. That's like your arm here. Your elbow is the fulcrum. The input force is here in the middle of your arm where your muscles pulling back. Right in the middle of your arm is pulling back, and that is moving the weight there. So those are your 3 types of levers. So let's watch this visual concept on levers.
A lever is a common type of simple machine. It consists of a fulcrum and a lever. The fulcrum is the point that does not move. Suppose we want to lift up a suitcase. The suitcase is very heavy, but only a small force is required to push down on the lever and lift the suitcase. The input force by the hand is smaller than the weight of the suitcase, but the lever allows the small force to overcome the large force by applying the smaller force over a larger distance. Although the suitcase undergoes a larger output force, it only moves a small distance.
Okay, so you got a lever here, and then when they say doesn't move, the fulcrum is the point that doesn't move. It moves, it's just a rotational. It doesn't move up or down like the ends where the weight is or where the applied force is. Alright, so lever family continued here. Pulleys are modified levers. The point in the middle of a pulley is like the fulcrum of the lever. So the very middle of the pulley where it kind of spins around, that's the fulcrum, and then there's a force applied to one part of it. The rest of the pulley behaves like the rigid arm of a first class lever. A wheel and axle is a lever or pulley connected to a shaft. So screwdrivers and crankshafts are common wheel and axle machines. Alright, so mechanical advantage of pulleys here. So you have on the left, you have a simple pulley that is fixed to a ceiling. So it's a fixed pulley. You have an input force here that's pulling the rope, and you have an output force that the rope is pulling up on the bucket, and the fulcrum, which is right in the center of the pulley, is the fulcrum about which the pulley moves. So you have an input and an output, and this kind of represents the rigid arm of the pulley. You have a different kind of pulley here where there's a string attached to the ceiling, and then the pulley itself is attached to the object, and then the force is input up. This is a little bit different pulley here, so when you're moving this up, this has a mechanical advantage of 2 because you have an input force of 75. What happens is it also feels another force here, tension of 75, so it basically doubles your force, which gives you an output force of 150 newtons, so a mechanical advantage of 2 if you're using forces. And then this arrangement of pulleys here, where you have a fixed pulley and a movable pulley here, and you have an input force of 50. This has a mechanical advantage of 3. You basically have, since you have 50 on this one, this string feels a force of 50, or tension force of 50, so it's going to pull a 50. This one also feels 50, so you have 3 times 50, which gives you 150 newtons there. Alright, so let's watch this visual concept on pulleys.
A pulley uses ropes and wheels to change the direction or amount of a force. Here, a downward force on the rope becomes an upward force on the bucket. This bucket weighs 150 newtons. Only one rope supports the bucket, so the rope must be pulled with the full 150 newton weight of the bucket. In this arrangement, 2 strands of rope share the weight of the bucket. 75 newtons of pull on the rope will support the bucket. More pulleys and ropes can be added to reduce the required force even more. This arrangement only requires 50 newtons of force. This is because 3 strands of rope, each with 50 newtons of force, pull upwards on the bucket.
Alright, so let's move along here. Inclined plane family. So how does using an inclined plane change the force required to do work? So pushing an object up an inclined plane requires less input force than lifting the same object does. Like if you're pushing a refrigerator up a ramp, it's a heck of a lot easier to push it up a ramp than lift a refrigerator straight up. So here you have an input force that is going along the ramp, and output force, the ramp's actually the one pushing the object upwards. Alright, so another visual concept here on inclined planes.
Let's think about trying to get the refrigerator here onto this truck. If we lifted the refrigerator straight up, it would require a lot of force. Let's label the required force F1. The distance we would have to move it, however, is relatively small. Moving the refrigerator up a ramp would require less force. We would, however, have to push the refrigerator a longer distance to get it onto the truck. It takes the same total amount of work to lift the fridge straight up or to move it along the ramp. Using the ramp or inclined plane, however, we can do the work with a smaller input force.
Okay, so you see here the comparison. The work's the same. You have a small distance here vertically, but you'd have to overcome a large force, or have to exert a large force to lift the refrigerator up. But F times D will give you a certain amount of work done. Same amount of work here, it's just less force over a longer distance. So it's a little easier. It makes it easier for us to accomplish the work over a longer distance there. Okay, so a wedge. A wedge is basically a modified inclined plane. And a screw is an inclined plane that's wrapped around a cylinder. Okay, so you see here, wrapped around a cylinder, that's an inclined plane. And a wedge is basically 2 inclined planes put back to back, and a wedge will split things. So let's talk here, or watch this little visual concept on screws.
A screw is in the inclined plane family. It is an inclined plane wrapped around a cylinder in a spiral. You would need to apply a very large force in order to push a screw straight into another object. But if you apply a small force over a long distance, you can get the same result. So as you use a screwdriver, you apply a small force over a large distance in order to move the screw with a large force over a small distance. A screw is usually part of the jack you use to lift up a car to change a tire.
Alright, so compound machines. What simple machines make up, say, a pair of scissors, which is a compound machine? A pair of scissors uses two first-class levers joined at a common fulcrum. Each lever has a wedge that cuts into the paper. So basically, what is a compound machine? A compound